Why does order matter in mathematics? Well, here I have the exact same problem twice, and we're going to solve it two different ways. So the first way, let's just work left to right. 16 plus 32, that would be 48. And 48 divided by 4 is 12. Now I'm going to solve this a different way. I'm going to say, what is 32 divided by 4? That gives us 8. And 16 plus 8 is 24. So you see I've solved this two different ways in a different order, and I got two different answers. Now which one's correct? In mathematics, we need to know one specified way so that no matter where you solve the problem in the world, you always get the same answer. That's why order of operations is so important, or precision, or repeatability. And the order we do in mathematics is PEMDAS. Parentheses, exponents, multiplication and division, addition and subtraction. Now this is actually better to write it not in the left to right way, but as the top to bottom way. This is more correct because multiplication and division are done at the same time, always working left to right, and addition and subtraction are done at the same time, working left to right. That's because addition and subtraction are inverses of each other, and multiplication and division are also inverses of each other. They're nearly the same operation, so they're done at the same time. Let me write down order of operations here to make sure we're following it. So we have parentheses first. So the first thing we're going to do is we're going to look right here. So I'm just going to pull it off to the side here. Oops. 2 cubed plus 4. And then when we're inside of the parentheses, we're going to follow the rest of the order of operations to solve this. So the next step is look at parentheses again. Well, there aren't any in the red 2 cubed plus 4. So we're going to move on to exponents. There is an exponent, 2 cubed. 2 cubed is 2 times 2 times 2 times 2. And that is 2 times 2 is 4. 4 times 2 is 8. We have 8 plus 4. Now we continue the order of operations. Multiplication and division, there is none here. And finally, addition and subtraction. There is an 8 plus 4. And so 8 plus 4 is 12. So we get 16 plus 5 times, this whole parenthesis thing is just 12. Now we can move on to the rest of the order of operations for the original problem. There's no more parentheses, so we don't have to worry about that one. We can look at exponents, and there are none left in the black. Then we can look at multiplication and division, and there are some there. 5 times 12. So we do 5 times 12 first. 5 times 12 is 60. And now we're done with multiplication and division. So we move on to addition and subtraction, and of course, that's the only thing remaining. 16 plus 60 is 76. So using order of operations, we should get 76 no matter who does it. Okay, for this problem, it's a little bit longer, but we can still use our order to solve it. So first off is parentheses, but there are none, so that's good to go. The next thing is exponents, and again, there are none of those. Now we look at multiplication and division. And for this one, we are looking always from left to right. So we're going to solve the first one we see, and going left to right. So 24 divided by 8, that's going to be 3. I'll write down the rest of it just so we keep the same kind of order here. Then still working with multiplication division, working left to right, we see 14 divided by 7. which is 2. And then the last one is 8 times 6, which is 42. Sorry, 48. Okay, so that one's done. Now we can look at addition and subtraction. Again, we work left to right. So 3 minus 2 is first, which is just 1. And then the last one, of course, is 1 plus 48, which is 49. All right, for this next problem, we have what's called a fraction bar in here. And the fraction bar is just a division sign, but it's a division sign that is between expressions. What we're going to do is we're going to consider everything on top and below the fraction bar in parentheses. If we do this, we will still, we should always get the right kind of answers, and the order of operations will be upheld. So here's the order of operations. So parentheses are first. We're going to look at the top thing and the bottom thing. So let's see, 6 plus 12 times 4. I'm going to look at this one first. Again, we run through order of operations for this quantity here. So is there parentheses in this 6 plus 12 times 4? No. Is there exponents? No. Is there multiplication division? Yes, it's going to be right here. 12 times 4, which is 48. Let me do that in black. And of course, the last thing is addition and subtraction. So 6 plus 48 is 54. So that goes on top. Now, the bottom portion is also in parentheses, so we're going to do that portion first as well. Again, run through order of operations for the things in parentheses. Is there parentheses? No. Is there exponents? No. Is there multiplication division? Yes, so let's do that first. 3 times 2 is 6. And of course, the last thing is subtraction here. 15 minus 6 is 9. And that goes on the bottom. So let's write what we have now. We have 54 on top over 9 on bottom times 3 squared. Okay, that means parentheses are done. There's no more parentheses in our original problem. We can move on to exponents. And we do have some exponents. Well, just one, I should say. 3 squared. 3 squared is 3 times 3, which is 9. Okay, exponents are done. Let's move on to multiplication and division. And now you see that we do actually have two things. We have a division right here and a multiplication right here. We always work left to right when we have multiple of the same, multiplication, division, or addition and subtraction. We always work left to right. The first thing we're going to do is this 54 divided by 9. 54 divided by 9 is 6. And then 6 times 9, that's actually just back to where we went, 54. So following this path, we should always get 54 as we follow correct order of operations. All right, here's a little bit longer of a problem. Let's write down our order of operations once again and go from here. All right, I'm going to add in some parentheses here in red to make sure we know where they are. And that's actually going to be where we start with the parentheses. So let's kind of write these off to the side. I'm going to do a little bit lower this time. Again, we have an addition and a multiplication here. Multiplication is higher in the order of operations, so we're going to do that first. 4 times 12 is 48. And 2 plus 48 is 50. Now the bottom quantity in the parentheses is 18 minus 4 times 2. we have subtraction and multiplication in this one, and you can see multiplication is higher up, so we're going to follow that one. So 4 times 2 is going to be first. 4 times 2 is 8. And then the last thing to do is 18 minus 8, which is 10. Let's rewrite this out with our new quantities. On top we have 50. On bottom we have 10. Plus 72 divided by 9. Okay, and as you can see, there's no more parentheses here, so we're done with that one. Let's look at exponents next. And we have one thing here with exponents. 2 cubed is 2 times 2 times 2. There's going to be 3 2's. So 2 times 2 is 4, times 2 is 8. So let's continue with what we have. And there are no more exponents, so that one's done. Now let's look at multiplication and division. And we have one here. This is a division there, and this is also a division. So we're going to work left to right. 8 times 5 is 40. Then we have 50 over 10. That's the next one. 50 divided by 10 is 5. And the last one we have here is 72 divided by 9. 72 divided by 9 is 8. Get a little room here. And so we're done with multiplication and division. The last thing on the order of operations is addition and subtraction. And you see we have both addition and subtraction here, but we always work left to right. So the first thing I'm going to do is the first thing I hit going left to right, which is the 40 minus 5. 40 minus 5 is 35. And 35 plus 8 is the very last operation. That gives 43. An electrician purchased 12 dimmer switches at $30 each and received a $6 credit for each of 3 duplex receptacles that she returned. And how much did she spend or receive? So let's look at this thing and kind of break it down to what she spent and what she received. So she purchased 12 dimmer switches at $30 each. So we have 12 $30 purchases, right? She spent money on those. So this is spent money. This isn't subtraction sign, it's more like an arrow saying 12 goes to 30. This is the spent. She received a $6 credit. So she received $6 for each of 3 receptacles that she returned. This is how much she received. Okay, so how much money did she spend or receive? Well, she spent 12, for each of the 12 dimmer switches, she spent $30. That means in total, she spent 12 times 30. And then, how much did she receive? Well, she received $6 for each of the 3 receptacles that she returned. So 3 times 6 is how much she received. So the difference between these two things will either tell us if she's spent money or received money. So we know that if she receives the 3 times 6, that's going to be coming off of how much she spent. Let's calculate how much she spent first. 12 times 30. You can use a calculator for that. That's going to be, let's see, 360, I believe. And then 3 times 6 is how much she received, which is just 18. So she spent 360, she received 18. If we subtract these two things, which is kind of what we're doing here, you'll see that she'll have spent a lot of money. Namely, this is going to be 42. She spent $342 total, because 18 of that was removed from the 360. And what we see here, this right here is a mathematical model for this situation. 12 times 30 minus 33 times 6. And you see the first thing we did is the multiplication, and then we did the subtraction. That's that we were actually following the order of operations naturally to solve this type of problem. Graphics company is charging $80 per hour for your senior graphics artist. Let me write that down. I'm going to do senior graphic artist is $80 an hour. The production designer is $40 an hour. And it's $18 per hour for a trainee. We'll do trainee at $18 an hour. So a project required 33 hours from the senior artist, 12 hours from the production designer, and 45 hours from the trainee. And what's the total labor cost? So the total labor cost is going to be adding up all of these things together, right? Because that's what gives us a total. Okay, so if the senior graphics artist worked for 33 hours at $80 an hour, that means the total labor cost for the senior graphics artist is 80 times 33, because that's how many hours they worked. The production designer worked 12 hours, and they are $40 an hour. So $40 an hour times 12 hours gives us the total labor cost. I should actually put a little bit of units in here. $40 per hour at 12 hours. And then the trainee at $18 an hour, they worked 45 hours. So the total labor cost is just going to be the sum of these things. Let's extract these numbers out with the signs that we're doing, or the operations. And this is what we get. Now, using order of operations, we know that we need to first calculate these amounts before we do the sum. Let's do that first. Let me grab a calculator here. 80 times 33 is 2640. 40 times 12 is 480. And the last one, 18 times 45, is 810. Now, because this is all addition, we just work left to right, and we just add them all up. So I'm going to do 2640 plus 480 gives us 3120 plus 810. Remove those. And this becomes 3930. And that's the total labor cost. All right, this is the last problem that we're going to be looking at. It's a caterer making or buying some strawberries for a 200 guest dinner. She needs 6 strawberries per person and 10 per person for dessert. 1 for decorations, 1 for dessert. And there's a farmer that sells 80 strawberries in a box for $7. How many boxes and how much for the cost? Now, in the previous problems, you may have seen the first thing I do is I'm extracting the information out of the problem. we're going to do the same kind of thing here. So we know we have 200 people that we're catering for. And there are 6 strawberries per person for decorations. 6 per person for decorations. And 10 per person for dessert. A farmer sells 80 strawberries in a box for $7. How many boxes are needed and how much will that cost? So the first thing we need to figure out is how many strawberries do we need? Well, 6 per person for decorations, and there's 200 people. That means there's 6 times 200 for decorations. And then there's 10 per person, and there's 200 people. There's 10 times 200 for dessert. And these, of course, are just going to be combined for a grand total of how many strawberries you need. So to do this, we need to use order of operations again. 6 times 200, that's 1,200. Again, I'm working left to right. And then 10 times 200 is 2,000. And of course, 1,200 plus 2,000 is 3,200. This is how many strawberries are needed. Okay, now to figure out how many boxes are needed, if each box that the farmer sells holds 80, then how many 80 strawberry boxes are needed for 3,200 strawberries? Well, one way we can do this is say, take 3,200 and divide it by 80, and that'll give us how many boxes we need. So if you're not sure, you can do that on a calculator. 3,200 divided by 80 gives us 40. We need 40 boxes at 80 each to cover how many strawberries we need for this dinner that the caterer is catering. To make sure, you can always do 40 times 80, and that'll give you 3,200. Now, that's how many boxes are needed. So that's the first question. The second question says, how much will that cost? Well, if a farmer sells 80 strawberries in a box for $7 and we need 40 boxes, then all we have to do is take 40 times 7. 40 times 7 is $280. That's how much it'll cost. Now, to kind of wrap this back up to what we were doing previously, let's write out the full model that we used for this data here. 6 times 200 plus 10 times 200 is how many strawberries were needed. Then we divided this number by 80 to get the boxes needed. Then we multiplied this by 7. And so if we were to solve this thing out, which of course we will get 280, it won't be in dollars because there's no unit on there, but if we solve this whole thing out using order of operations, that's what's going to get us to 280. I should say you don't necessarily need to, create this equation that you have to use PEMDAS for. You can do this in the parts that we were kind of doing up here. We were solving how many parts and then, solving each one of these things individually. But this is just the tying in of the order of operations that we were learning about previously in this video.